Hello everyone. So here we have a nice problem that goes over the concepts of trigonometry, and we have to calculate the area of an internal hexagon formed by the points P, Q, R, S, T, and U. Now they have given us that the area is in the form of root n over t, and we have to figure out the integers n and t to make t as small as possible. Okay, so we have to figure out the area and then convert it in form of root n over t. Both n and t are integers, and mainly calculate what is the ordered pair here. Okay, now other than that, they have given us some of the critical information. One such thing is that the six interior angles of the hexagon that is made by point A, B, C, D, E, and F are all equal. Okay, now if you recall that from the theory of hexagons, that the sum of internal angles of a hexagon is equals to 720 degrees. Now since we have six of those and all of them are equal, so each one will be equals to 120 degree here. So I have 120 each one in this case. Okay, now they have also given us the two sides, so BC and EF is equals to 6, whereas all the A, B, C, D, DE, and FA is equals to 2. So I have AB equals to 2, same as AF is also equals to 2 here. Okay, now to figure out the area, one way of doing that thing is I can divide my internal hexagons into triangles and rectangle. One rectangle here, and then I have the two triangles that is above and below this rectangle here. Okay, so I'm interested in calculating this length PQ. Now to calculate the PQ, let's see how we can do that. I have a triangle A, B, and F, and two sides of the triangles are known, and the angle between those two sides is also known, that is equals to 120 degrees. So we can utilize the cosine law to calculate the third side. So BF is equals to root 2 square plus 2 square minus 2 times the two sides and the cosine of angle between them. Okay, so if we simplify this, this becomes 8 minus 8 cos of 120 will be negative 0.5. So I have root 12, and I can further simplify this thing into 2 root 3. Okay, so this is the length from B to F here. Okay, but we are interested in length PQ. So to do that, let's see, let me draw a point in the middle of it and have this guy here. Okay, so let me define this thing as a point Y. So my length from B to Y will be equals to root 3 here. Okay, and from that we can form a right angle triangle here. Okay, so that is one thing. Now one other thing, if you look, I have these diagonals from A to C, and this is identical to my diagonal from F to D here. Okay, and I can use the similar triangle principle here. So if I drop a vertical down a straight line and make it a right angle triangle. Let's say this point is Z here. The distance from D to Z will be root 3. That is just what we have calculated. And the length from F to E is equals to 6. And I have this unknown value. Let's say this is equals to X for now. And we also know the distance from E to D, that is equals to 2. Okay, so if that is the case, I can figure out my X using the Pythagorean theorem. So the value of X will be equals to 2 square, that will be 4, minus root 3 square, that will be 3, and a square root of that equals to 1. Okay, so this value is equals to 1 here. Now this triangle EDZ is identical to my triangle ABY, as the two sides, this is equals to 2 and this side will be root 3. So I have this as 1 as well here. Okay, so that is one information we have. Now other than that, if you look at triangle FDZ, this diagonal F and D, that is making an angle of theta with the horizontal. And if I compare this to the triangle APY, that is also making an angle theta from the horizontal, as these two lines A and C is parallel to F and D here. Okay, so if that is the case, I can compare these two triangles, as these are the similar triangles we have. So to do the comparison, I can take the ratios of the sides of the triangle. So let's see here, I have 6 plus 1, that is 7. That is for triangle FDZ, that is similar to triangle APY. So 7 divided by 1, that is equals to root 3 divided by PY here. So PY will become root 3 over 7. Okay, so if I have PY equals to root 3 over 7, and the distance from P to U will become twice of that. So the value PU is equals to 2 times this guy. Okay, so now I have basically the sides of the rectangle that we were looking for. So I have this guy and this guy, that is equals to 2 root 3 over 7, whereas this long side is equals to 6 here. So we can calculate the area of the rectangle in this case. Okay, so we'll do that in a bit, but we still have to figure out the areas of the two triangle that is above and below this rectangle here. Okay, so to do that, let's again look at this diagonal here, and this is again making an angle from the horizontal. So this is again, the angle will be theta, and we can again compare the sides to figure this thing out. So if I drop a vertical from point Q downwards, making a 90-degree angle. So I have my triangle PQ. Let's put me a variable as let's say we don't have M here, so let me make it M. So I have PQM, and that is identical to my triangle FDE. and Z here. So let me do it here. That triangle PQM is similar to triangle FD and Z. So again, we can compare the sides. I have 7 divided by half of 6, or 3, equals to root 3 divided by QM, and we can get the value of QM, that is equals to 3 root 3 over 7 here. Okay, so once we have this distance, now I can get the area of this triangle here as well. So let's compute the area of this triangle. That will be equals to half times 6 times 3 root 3 over 7, and that is becomes since we have 2 of these, I can multiply it with 2 to get both the areas of triangles. So let's simplify this. This becomes 18 root 3 over 7. Okay, so this is my triangle areas. Okay, now once we have this, let's uh, figure out what will be the area of this rectangle here. So I have 2 root 3 over 7 times 6, that will be root 3 over 7 here. Now we can combine both the area. So I have the area of the triangle plus the area of rectangle, the area of 2 triangles, and the area of rectangles. That will become 18 root 3 over 7 plus 12 root 3 over 7. That will be equals to 30 root 3 over 7 here. Okay, now in the problem they are asking us a specific form of an area, that it should be in the form of root n over t. So we have to convert this 30 root 3 in a form of just a square root of an integer number. Okay, we can do that by just squaring the numerator and figuring that thing out. So if I square the numerator, that will become 900 times 3. Okay, and then since I have squared it, I have to take the root again. So this will become root 27 over 7 here. Okay, so our ordered pair of n and t will be n is equals to 2700 and t is equals to 7. Okay, I hope you like this problem.